Assalamualaikum and hi everyone. So in this video we are still in chapter 3.2 periodicity, but I'm going to discuss learning outcome B, compare the atomic radius of an element to its corresponding ionic radius. Okay, so let us start with variation in ionic radii, okay, or ionic radius. Okay, so first we need to compare cation and its atom lah. Okay, so as we can see over here, so the radius increases as we go up. So the size of the cation is smaller than its atom. Okay, so cation is always smaller than its atom. That means we are comparing the same element here. For example, lithium dengan lithium ion. Okay, sodium dengan sodium ion. That's why dia guna perkataan its atom. Okay, to show that itu adalah benda yang sama, cuma dia jadi ion. Cation dia akan always smaller than its atom. Okay, while for an ion, we can look at this diagram here. Okay, so an ion, the size is always bigger than its atom. Okay, for example, fluorine atom and F minus ion. F minus ion has a bigger size than F atom. Okay, and the same goes for the rest of the anion. Okay, so this is what we need to explain lah. Kenapa size cation always smaller than its atom? Kenapa size anion always big? Okay, so the explanation is here. Okay, so this explanation is for cation. Example that I will use here is sodium ion and sodium. Okay, so the size of sodium ion, which is cation, is smaller than sodium atom. Okay, so this is the electronic configuration for sodium and sodium ion. So the difference is sodium dia memang dua-dua ada 11 proton lah. Okay, cuma beza dia adalah dia punya elektron lah. Bila dia neutral, that means 11 proton equal to 11 electron lah for sodium yang neutral. That's why 1s2, 2s2, 2p6, 3s1 dekat atas ni. Tapi when sodium tu jadi sodium ion, that means dia punya charge dah jadi plus 1. Okay, please remember charge plus 1, that means kita remove, okay, kita remove one electron. Okay, so when we remove one electron, we must remove the electron from the outermost shell, which is from the 3s lah. Okay, so that's why no more 3s here. So we are left with 1s2, 2s2 and 2p6. Okay, so right now we have 11 proton and 10 electron dalam sodium ion. Okay, cation are formed when electrons are removed from the atom. That means when we want to form cation, we must remove electron lah. Okay, so when we remove the electron, the effective nuclear charge increases. Okay, so kenapa effective nuclear charge increases? Okay, so jom kita buat pengiraan lah dekat sini. So kita dah tahu before this, Z equal to Z minus S. Z adalah proton number. Okay, so if we count Z for sodium atom, okay, so there are 11 proton minus with inner electron. Okay, so there are 1, 2, 3 shell over here. So that means shell 1 and shell 2 is the inner shell lah. Okay, shell yang dalam. Okay, so dalam inner shell ni ada 2, 4, 10 electron. Okay, so 11 minus 10 equal to plus 1. Okay, so effective nuclear charge for sodium is plus 1. For sodium ion pula, jom kita kira. Okay, so effective nuclear charge, the proton number is still the same, which is 11. But now, we need to determine the inner shell. Okay, so there are only 2 shell right now. 2 shell je. So, that means shell 2 ni adalah dia punya outermost shell. Okay, so dia punya inner shell automatically adalah yang 1s tu lah, adalah inner shell. Okay, so maksudnya dekat sini, kalau ini inner shell, 11 tolak 2 elektron lah. So, the effective nuclear charge is plus 9. Okay, so if you compare, okay, the effective nuclear charge is higher in sodium ion. Okay, so that's why dekat sini dia cakap, when kita remove electron from the atom, the effective nuclear charge increase. Okay, kita remove satu elektron je, tapi dia menyebabkan effective nuclear charge tu meningkat. Okay, so kita dah tahu before this, if the value of effective nuclear charge is higher, that means the force of attraction between nucleus and the outermost electron getting stronger. Okay, so bila attraction tu makin kuat, apa yang terjadi adalah kamu boleh bayangkan kamu adalah nukleus and then you pull the electron kuat, tarik dengan kuat elektron tu, so the electron will become closer to you lah. Okay, so the remaining electron are pulled closer to the nucleus. So bila electron tu closer to the nucleus, that means the size of the cation will be smaller than its parent atom. Okay, right? So hopefully boleh faham yang konsep ni. That's why saya cakap before this, it is important for you to be able to understand ZEF dengan shielding effect betul-betul. Then yang lain baru kamu boleh explain dengan betul jugalah. Okay, next we want to explain the size of an ion pula. Okay, so the example that we use here is chlorine. Okay, chloride ion dengan chlorine atom. Okay, beza dia adalah Cl ada negatively charged. Negative charge means kita tambah elektron. Okay, so bila kita tambah elektron, kita akan tambah elektron dekat outermost shell juga. That's why over here 3p5 become 3p6. Okay, so an ion are formed when electron are added to the atom. When electrons are added to an atom, repulsion between electron increases. Or if you don't want to say repulsion between electron increases, you can say shielding effect increases. Okay, so kamu boleh bayangkan elektron dengan elektron, dia punya sifat dia adalah dia akan repel each other. Dia akan tolak satu sama lain. Okay, so bila dalam ni dalam klorin yang biasa ni dah ada banyak dah elektron, 17 elektron. Then you want to add some more elektron. Okay, so elektron yang di dalam tu akan tolak elektron yang baru nak masuk tu lah. Okay, so itu bila berlaku tolak menolak antara elektron, itu juga yang kita panggil sebagai shielding effect, mutual repulsion between electron. Okay, so bila mutual repulsion between electron increases, okay, the repulsion will cause the electron to spread out. That means macam bila kita asyik tolak menolak, so dia akan spread out lah. Okay, dan experience less attraction to the nucleus. That means the electron akan makin jauh dari nucleus. So dia akan rasa kurang lah attraction terhadap nucleus. So as a result, an ion always bigger than their parent atom. Okay, so as you can see over here, untuk an ion kita tak guna ZEF, tapi kita akan guna shielding effect. Sebab apa yang bertambah dekat sini adalah bilangan elektron yang bertambah. Okay, kalau kamu kira ZEF, kamu kata kenapa tak guna ZEF? Okay, kamu kiralah ZEF for both. Okay, kalau kamu kira ZEF untuk kedua-dua ni, kamu akan dapat jumlah yang sama. That's why we cannot use ZEF over here dekat anion, tapi kita kena guna shielding effect. So I think that's all for this video.